Welcome to another Science Break. My name is Joe Maglotti. I'm a volunteer with the Merck Institute for Science Education. Today, we'll be talking about polymers. Polymers are all around us. We see them in our household with toothbrushes, plastic knives and forks, plastic soda bottles, even Tupperware. Everything is made out of polymers. Polymers stands for many parts. Poly meaning many, mer meaning a part. Think of a freight train. It has many cars. Each car is a part. If we put them together, we formed a polymer train. You might be aware of some of the toys that are in toy stores known as slime or gack. Today we'll be making some gack so that you can make that at home with a little bit of Elmer's glue and some borax. The chemical names for glue are polyvinyl acetate and borax sodium tetraborate. But these are big words, but we'll be able to make some gack, which is a small word. We'll make some gack by taking some Elmer's glue and mixing it with equal parts of water. We make the borax solution by taking 1 tablespoon per cup of water and mixing that until we get our borax solution. To make a colored gack, we'll take some food coloring. Today we'll be using some green. We'll add a few drops and mix it up so that we have a nice green color. If you would like to have it a little bit darker, just add more food coloring. Now, to form the gack, we will add some of the borax solution to the Elmer's glue. Stir it up. What do you notice happening? What do we see in our cup? The gack is starting to form. After a few minutes, you can take the gack out of the cup and start playing with it. It'll be a little slimy at first, but if you move it around, it'll start to solidify. You can use a paper towel to wipe your hand, but don't put the gack in the paper towel. It'll begin to stick to it, and then you'll never get it off. After a while, you can play with the gack just as you would with silly putty. You can break it, much like a solid breaks, or you can just let it sit there in your hand, and it'll ooze much like a liquid. To recap, polymers are all around us. You might even think of them as plastic type material, and you can see that in the material that you've made. It almost feels like plastic. So today we've made a polymer that we call gack. Gack is fun to play with, but be careful. Don't get it in any furniture or in any carpeting. It sticks and it won't come out very well. Also, being a scientist, you won't want to taste it. Scientists don't taste anything. Gack doesn't taste very good. You can store gack in a baggie overnight in the refrigerator, and you'll have loads of fun with it in the days to come. For North Penn Television, I'm Joe Maglotti.
Welcome to another North Penn Science Break. I'm Donna Brown from the North Penn School District, and I'm here today to show you some things that you can do at home to experiment with science. This one takes hot water, so you're going to need an adult's permission or work with an adult to try this experiment. For this experiment, you're going to need some butter, the hot water, a plastic knife, a metal knife, and some sugar cubes. What we're going to try is to pour some of the hot water into a mug, and make sure it's the kind of mug that can take hot water. I'm going to put some butter on the plastic knife and stick a sugar cube onto the butter. Put it in. We're going to do the same thing with the metal knife. And we're going to watch and see what happens. What do you think will happen? Remember, this one is a metal knife, this one is a plastic knife. You may have had some experience with trying to touch a metal spoon after it's been in a pan with something cooking. This is the same idea. It's a big word for kids. It's a word called conduction. And it has something to do with the hot water. You can see that this water is very, very hot, and there's some steam coming off of it. Whoa, there goes the butter. Hey, wow, when that slides in the water, you sure do have buttered water, but interesting. And this one isn't doing anything. In fact, it's barely warm. So what that shows you is that metal is a much better conductor than plastic. You might want to try this with some other things that you might have at home. Maybe there's a popsicle stick. That would be a good one to try. And do the same thing. Try to get the butter and the sugar at the same height with the metal, the plastic, and a popsicle stick. See what happens. What do you think will happen? Guess first, and then go ahead and test. See you next time on Science Break. Welcome to another North Penn Science Break. Today I'd like to show you something you've probably seen at the supermarket. Good old red cabbage. Do you like to eat it? Maybe, maybe not. But I'll show you something really fun you can do with red cabbage. If you want to try this, and this is just a regular knife, you might need the help of an adult or an older brother or sister. The cabbage needs to be kind of sliced up so that you get kind of small pieces. And what I did with it was put it into a nice mug that's safe to heat. I added some water and I put it in the microwave. So if you're going to use a microwave, you need to make sure there's an adult around. So I made cabbage soup. Not very appetizing, but there's a neat thing you could do with cabbage soup. If you look at the liquid, it's a beautiful purple color, almost the same color as the cabbage. And I'm going to put some in a plastic cup. This purple cabbage liquid is so unique, it will let us find out what some other substances are. I'm going to add some dishwashing detergent, and this happens to be a lemon-based one, kind of flavored and smells like lemon. And if I add this detergent and kind of slosh it around, you'll see that the color is now very different. It's almost like a blue-green color. I'm going to add some more cabbage juice. I have to watch out I don't get too many pieces of cabbage in there. And you can see how different the dishwashing liquid is, because one of these liquids is nice and purple and the other is kind of a bluish purple. And I'm going to add some squeezed lemon. And you may have some of this at home in your refrigerator. And we'll see if we can just squeeze some lemon in. Oh, wow, look at that. Another very different color. This is what's called a test liquid. Purple cabbage juice will change color depending upon what liquid it's in. Whether the liquid is something called an acid, which is what we find in lemons, and acids are the kind of things that make your mouth kind of pucker, or whether something is called a base, like you find in dishwashing liquid. Since this is a very safe type of chemical that you find in cabbage juice, you might like to try to test some other things at home. Maybe you'd like to test your apple juice. Maybe you'd like to test some Sprite, some of the things that you like to drink or eat. And this is a safe thing to do as long as you ask for permission. Have fun trying to test some of the things you eat and find out if they're acid or base. For North Penn Television, I'm Donna Brown. Hi, welcome to another North Penn Science Break. Today we're going fishing. What we have is a tank of water and some paper fish. If you look closely at these fish, you'll find they're a little bit different. They have a very long fin. They're kind of cut up the middle, and there's a little hole right about in where the fish's stomach would be. We're going to have the fish float in the water and see if we can make him swim. So I'm going to set the fish in the water, and I'm going to add, where the little hole is, some dishwashing liquid. There goes the fish. Amazing. You can try this at home. So what you need to do is make a paper fish. Make your favorite shape of fish. It can be a small one, depending upon the size of the tank you've got. Just make sure that you have a couple of long fins and a little hole in the middle. And you can drop in a drop of any kind of dishwashing liquid and make the fish swim. What happens if you try to make a bunch of fish swim? Try it and see. You may be surprised. For North Penn Television, I'm Donna Brown.
Hello and welcome to another North Penn Science Break. My name is Joe Maglotti and I'm a volunteer with the Merck Institute for Science Education. Today we'll be talking about rockets and how do they work. If you're like me, I'm an avid model rocket fan and I like to launch them outside. But sometimes it's not too good outside to launch them, so I like to launch them inside. Today we'll be launching a rocket and showing you how to do that. What you will need is an effervescent tablet, a Fuji film canister, and a paper rocket that you'll be able to make. Make the rocket by taking a film canister and wrapping a piece of paper around it till it's very tight. Then take some tape and seal the rocket tube so it doesn't fall apart. You can make the fins by cutting out piece of paper like this. It looks like a triangle with about a 1-inch flat piece in the middle, and then bending it so it looks like this. Take your fins and tape them onto the rocket as such, one on each side. When you end up with your rocket, it will look like this. Put a paper nose cone on also to finish it off. To launch our rocket, take the film canister and add some water until it fills about halfway up. Then, take an effervescent tablet that's been broken into 4 pieces. Take 2 of the pieces and add them to the film canister. Put the top on and put it inside your rocket.
10, 9, 8,
and wait for it to
7,
launch.
Ignition sequence started. All engines are started. We have ignition. 2, 1, 0. We have a liftoff. We have a lift.
There, how's that? Pretty neat. You can do this many times. Let's try it again.
We have a liftoff, and it's lighting up the area. It's just like daylight here at Kennedy Space Center as the Saturn V is moving off the pad. It has now cleared the tower.
Missed. I hope you enjoy doing this at home. Remember, get an adult to help you, especially when you're working with tablets and film canisters that are really exploding. Rockets work in the very same principle, something that Sir Isaac Newton discovered in the 17th century. For every action, there is an equal and opposite reaction. What we had today was the cap from the film canister blowing off in one direction and the rocket taking off in the other direction. That's science, and I'm Joe McGlotty for North Penn Television.